sense.
Okay, so we're gonna get started, and I think the first thing we can talk about, especially just to get the flow right, is to talk about the case study. And yeah, so case study one, the marriage rate usually, and I will download all of the reports that you have done, but I think for the first 10 or so minutes, you can check with your people sitting next to you, because I think most likely it's not the person who you work with for the case study. So maybe you can explain to the person next to you about what you did, and especially like keep those questions in mind, the one that we had. Say, marriage rates before, during, and after World War II the same, and what are the Bayesian methods, assumptions, how can you justify your assumptions, and then of course, how did you do your MCMT simulation, all that. Okay, so I'm going to give you the time and space to talk to the neighbor next to you, and what we're going to do in terms of discussion or sharing what you have done is I will put up all of the reports on the screen, and then whoever wants to talk about what you did, I will just share the screen when we're going through that in the front. Okay, so now just take the time to check with your neighbor and discuss what you have done and see the similarities and differences. Okay. So I will put the question up here, and I do have, I think, 12% reports that I can put up. So anyone wants to start the, like maybe describe what you have done in the report, like the way that you analyze the data, and then maybe talk to us about the Bayesian methods, your parameters, and then the conclusion that you have. So anybody wants to start? We're trying to see if we can come to like a final, agreed on approach that we can convince each other, or we can actually end up with multiple approaches, but each has its own pros and cons. Okay, anyone? Okay, Caroline, so I'm going to bring up, so let me see how I can share things more. Nope. This one. Yeah. Caroline did it with Kellogg from Amherst. Yes. Okay. Yes. Okay.
Yeah. So since these are marriage counts, we chose a Poisson data model. And so we had a different lambda for the 3 different time periods, but all of the lambdas followed the same prior distribution. So it's that hierarchical modeling idea of some shared information, but not exactly the same. And then for the parameters of the gamma, A and B, we chose to have them both follow the uniform distribution 0, 2, so that you would have sort of a vague gamma prior close to 1, 1. And we just didn't want any extreme values or any negative values. And so then we used JAGs, and we used the same amount of burn-in and samples that we had done in class for the K-drama data. And even without any thinning, we got a high effective sample size, and there wasn't really any stickiness in the trace plots, and the autocorrelation was very low. So we felt like the chain did converge, and then we just looked at the posterior summary, which is actually up above the trace plots. And because the mean and median for the 3 lambdas, the posterior estimates, were different, and the confidence or the credible intervals were shifted, we concluded that the marriage counts had changed from before, during, and after World War II.
So maybe I just have a quick question. So when you have the lambda J, so how did you define the 3 periods?
So that was based on the year. So if it was before 1939, it was before, and that was lambda 1. If it was between 1940 and 1945, that was lambda 2, so during, and then if it was 1946 or later, it was lambda 3 after.
All right, any questions from other people in the class? Comments or like say, did you use similar approach? And if not, and yeah, if yes, maybe talk a little bit about why you did that. And if not, what is the difference that you're like different approach that you're having, and then do you think, yeah, so maybe I would end here with the posterior summary because that's what Caroline was talking about. I guess it's the mean and median, right? About this lambda 1, 2, 3 in this case. And right, so lambda 2 or lambda J2, lambda 2 I should say, is the smallest among the 3. Whereas I guess before and after, I mean, they're slightly different, but not that much. Whereas there's definitely a big, there's definitely a big drop, right, during the time. Other comments, approaches? Did you all use the same method? Okay, Josh. You just shake your head. That's it. All right, so let me bring.
I have a quick question though. May I ask?
Oh, sure.
Did you also figure out if it's not just different, but also if a certain period had a higher marriage rate than the other?
So we just looked at the mean and median. So the lambda 3 has the highest, and then lambda 2 during the war has the lowest.
Okay. Do you want to follow up with your approach?
Well, I guess that's the only right answer right now, right? Jessica.
Okay, so I will ask Jessica.
Oh.
Well,
Well, both of us can explain. Doesn't
give me
matter.
a second. So let me. I see. All right, Jessica, do you want to start?
Okay. So we use a beta binomial approach. And so we found the averages for the pre-war period, the post-war period, and the war period. And then we picked our own beta priors based off like the data itself. So for the pre-war period, we picked the priors of 2, and then for as we progress, we increase the B value because we realized that it would, the graph would skew towards the right. So we would expect that marriage rates would be decreasing. So that we picked 2.5 for the war period and then 2.9 for the post-war period. So then we estimated our posterior distributions using beta posteriors. And then based off of these posteriors, then we use the MCMC. We run drugs to get the MCMC diagnostics.
So they're down here, I guess.
Yeah, just to give more context, I first looked up, since we don't have any knowledge about prior distributions, I just looked up several research papers that dealt with marriage rates in Italy, and then it kind of said average marriage rate kind of decreased over time as they went through war. During the war, obviously goes down because a lot of males die in the warfare, and then females don't have enough people to marry, so marriage rates go down. And after war, because of the post-traumatic experiences, people are more iffy about getting married, so the marriage rates are overall lower than the pre-war period. So we're trying to reflect that into our prior distribution. So the pre-war prior distribution, we chose beta 2, 2, which kind of resembles normal distribution. And then for the war period, we chose beta 2, 5, which is slightly more skewed to the right, it's longer tail to the right. And then for the post-war period, we chose beta 2.2, 9, which is even more skewed. So that was our prior beliefs, and we wanted to see if the data we have can sharpen our beliefs and will allow us to see if the prior beliefs we have are still valid after we use the data to sharpen it.
So should I come to, I guess, is there a summary output in the end that we can
Yes.
compare the results, or
Yes,
or
there are
is it towards up?
tables at the bottom.
Okay, is this one?
Yes.
Uh-huh.
So as you can see, the average marriage rate is the highest for pre-war period, and then it kind of goes down. It's about the same for the war period and the post-war period. So we kind of concluded that even after we use the data to sharpen our belief, our prior beliefs still hold. Yeah. And
Did you divide the data by 1,000 first?
divide which value?
All the data, did you divide them by 1,000 to get like a number
The
between
proportion?
0 and 1? Yeah.
So I just specified the y as like the count, marriage count, and then I specified n to be 1,000. So.
Okay.
Yeah, because this is a known distribution, so we could just use like y, a, b, and n to calculate the posterior distribution parameters.
Yeah, so I guess Caroline's question, and also my question as well, is because it sounds like you're working with proportions, right? Because otherwise you wouldn't use a beta prior distribution, right? So is that the question about, like,
Yeah.
are you working with the proportion or the y themselves?
The proportions.
Okay. Yeah, it's definitely, I mean, looking at the outcome, I'm sure it's on proportion, I guess it is, like, we have to look into the write-up to see. But by the way, all of the write-ups are on Moodle, so if you want to access on your computer, feel free. But when we're looking at this posterior summary of the 3 periods, I think, I mean, they seem to be proportions overall, so I'm guessing it is working with the proportions as the data. Other comments, questions? So I guess this is approach that you treat the 3 periods separately from each other, right?
And that, I guess, can be a limitation because we're assuming that those 3 periods are independent, but considering the characteristic of time series data, each year is influencing the next year value, which we didn't account for. So I don't know if there's a way to account. I'm sure you know.
But so I mean, if it's time series per se, like, we won't get the chance to cover it in class, but that's a way to think about it because, well, you do have, like what Josh said, the next year's data depends on the previous data. So that will be, typically people would do some type of regression in a sense, but of course, like, the error term will be slightly different from what we've been doing in class. But I guess also maybe another approach, especially if we're considering like hierarchical model, I wonder if there's a way that we can link the rates in some way, like say the AB. I was sorry, not the AB, but it is the AB. No, what are the? Oh, it is the AB. Sorry, it's the A and B that you chose for pre-war, during war, and post-war, right? So I wonder if there's a way that you can link all of them together in some sense.
I think some other teams use hierarchy-based models.
Using the beta binomial.
I'm not sure.
Anybody else worked with the beta binomial? Or mostly Poisson gamma? Or something else? Anyone? Anyone wants to, like, say, volunteer talking about if you worked with Poisson gamma, did you think about beta binomial and why did you make the choice when you were deciding on the model? Anyone? Okay, Caroline?
So I worked with Poisson, and I think my main reason for doing that was just because the data that we had was already in count form. So it would have been an extra step to convert it to proportions. But also I thought it might be easier to get good simulated draws using Poisson because there's only one parameter. And so for each period, you would only have one parameter to sort of be concerned about.
Yeah, so the Poisson model will have fewer parameters to work with. That's for sure. But I guess I also see Josh and Jessica's approach in the sense that because the beta prior is probably easier to specify based on what we understand, whereas gamma prior is less intuitive overall. I mean, if you sketch, like if you plot a lot of them and then, well, I take that curve, then that might be the way. But then we talked about the beta binomial at the beginning of the semester, how you can specify a beta prior to reflection or prior to leave in terms of how, like say, whether to skew to the left, skew to the right. So I guess there's certain merit doing that. I would just say maybe most likely people would do a gamma Poisson through a hierarchical model because it counts, and that's also just like the main reason because of the data is given in terms of count. Okay, so, but again, I mean, it's open-ended, so I don't think one way is definitely better than the other. But I do want to maybe bring up the previous discussion here really quick, that because I do want to see how others are approaching. So if you are using a gamma Poisson and maybe through a hierarchical model, did you all choose this approach in terms of how to set up the hierarchical, or any other possible approaches that you can set up the hierarchical? And this, I think, actually links to the video that we saw provided by Professor Gileu about different ways to set up a hierarchical model, like in terms of what are you actually sharing, right? Like you have many parameters that you can share across them, like the same prior distribution or something. So Caleb and Caroline is this one, that you break the data into 3 periods, and then for each period you have the Yij being IID Poisson with the given lambda j. Okay? So do we all do the same thing? Okay, Zach?
Well, we used a normal gamma hierarchical with shared standard deviation between groups.
Okay, let me bring that up. So I guess this is a new approach. So this is doing, so let me see. Maybe I will, yeah, maybe it's easier. Let's look at this one. To look at the,
So like our reasoning was just like, there's like, seems pretty sensible to believe that it's mean like marriage rate, like think of it as like perfect 1000, like that this is like higher before or after the war than during it, because logically like there's less eligible bachelors or something like that. But like didn't really seem super sensible that like within those 3 schedules there would be like within a lot of within group variation. Or so like we thought like we could just have a shared standard deviation. That's what we did, and we had like a really big prior for tau. We had like gamma 1,1, I think.
Yeah.
And then the shared one was it's normal 7,2 for the schedule means, and then 5,2 was the gamma prior for sigma, I think. Or something, I can't even remember.
For tau, I think.
Tau, yeah, and then the 1,1 was because we thought that there wasn't much like between group within group variability. Yeah, sigma's within group variability, sure.
Right.
And so
Maybe let me jump to the result here.
So it's pretty high effective sample size, like pretty low autocorrelation. Well, it's negative. Don't really know what happened there, but I think it's like, and then we just looked at the summary statistics, like the posterior mean, and like it looked like one of the 2 was the during war, so like 1939 to 1945. It's like pretty low compared to the other ones, 6.4, 7.75, and almost like 8.1. So.
And that's very similar to the results. I mean, not exactly the same numbers, of course, because it's different models and capturing different things, but definitely, I guess, mu J2 or like lambda J2 earlier were the lowest, whereas the other 2 closer, higher, but like sort of close to each other. Yeah.
So we just said that, it was kind of like different before and after war too, but like the real conclusion was that like during the war it was like definitely less than before and after. So.
Yeah, good. So I guess this is approach that you also break it into the 3 periods, but you're using a different data model, and then together you're using a different prior. Yeah.
I think something that was a little funky that we did though was our tau was mean 7 and standard deviation 2, but we kind of went off. We didn't know anything really about Italian marriage rate, so we kind of actually like looked at the data and kind of used the data to get our prior, which is a little backwards way of doing it. So if like we were to do it over again, I would say like we could have like maybe went to, I don't know, found some other data set and looked at a longer period of marriage rates in Italy and had a better prior, I guess.
Right.
More
So I guess, the summary, I guess, about tau is, well, around 7 around 0.7, the range is from 0.5 to 1, right? But you're talking about
Or-
choosing the prior.
Yeah, she's in the prior
Yeah,
side, yeah.
mhm,
Yeah.
over here, right?
Yeah.
Yeah. Right, yeah, so that's the thing, but that's a good comment. And I think it's good to keep in mind that, well, you can always, because the power of using Bayesian methods is if you have some other information previously or from other studies, then you might be able to use them to inference your results. Okay, so all right, so still like this is breaking into 3 different periods, but then using different data model and the different prior choice. But again, JAX is pretty powerful in terms of what you want to do. I just mentioned like here, I think some people use this way to code the periods. That's fine. And I saw earlier, Caleb and Caroline, you have a different like writing a function. So whichever is fine. And so you can like explore other other things people have done to make sure that you can make it work in your case. Okay. Yeah. Right. Anything else? Any other data model that we used? Or any other way of specifying the hierarchical model? Let me just bring this up. That's earlier on. Yeah. Other comments, ideas, or other possible approaches that you can think of?
I wonder how the result would have been different if we also specified the standard deviation to be different for each period. Because in
if
the-
you work with the normal model.
Yeah,
Yeah.
in the data, because the pre-word period's standard deviation is very close to 1, as opposed
Oh, I
to the
see.
word period, and the post-word period whose standard deviation is about 0.8, 5-ish. So there's some difference. I mean,
Right,
there might be an argument about how
right.
similar that are. But
Yeah. Okay, yeah, so among the 3, I mean, they're all hierarchical in some way, but among the 3 data models, I think probably the best one to use in this case is Poisson and Gamma, okay, because of the nature of the data. You know, when you work with counts, yeah. And what I would just add to the entire discussion is if you look at the way that it's being done in equation 1 here, in terms of how hierarchical it's done, I guess it's also because maybe I asked the questions about before, during, and after, so it's natural that people break it into the 3 periods. But sometimes you might just do a hierarchical model that you have a different lambda for each of the year, okay? But you still put like the same prior. So in this case, instead of doing like say a j or I, what you can do is like yi, iid, and then Poisson lambda I. Okay? And then all of the lambda, so you have what, 11 different years in this case, I think, or 12 during this whole period. And then each of the lambda I or j, whichever you name it, can be sharing the same prior distribution. Okay, so for that, you will get a bigger summary in terms of like the size, because you're gonna have different lambda j's for each of the years. Okay? And that might tell you, like, that might give you some extra information. But of course, that will give more parameters to estimate in the model, and you're still using the same size of data. So there's sort of like balance they're trying to strike over there. But that would be my only other thing I would add to, if we're going to focus on the hierarchical gamma Poisson, then it will be about, well, how we want to do the hierarchical. Okay. And in class, we've been doing, like, say, the demo that we did is only sharing all of the mu j, but not the sigma, right? And we had the discussion. Yeah, by the way, that that video was never recorded. I just couldn't load it on Moodle. But anyway, on the YouTube. But it was the exercise that we talked about. It's in the slides talking about what if you have mu j and sigma j, both of them being shared. So you can consult the slides to see if you missed the lecture that day. And yeah, so for here, either you break them into 3 periods and then have a shared period-specific lambda j, or you're just using each year differently, but then letting the 12 or 13, I forgot, or 11 years all together to be shared with the same prior distribution. Okay. So yeah, if you get the extra energy, you might want to check it out to see if you get the same results or like similar results. But of course, when you look at the summary here, all of this are like period-specific lambda, right? The rate. But then if you have a, I wouldn't say bigger, but more flexible model that like I described, that you have a year-specific lambda, then you're just gonna have a year-specific summary. Okay? And then you might be able to see certain trend, I don't know, within a particular period if you see anything extra. Okay? So that will be another approach. And anything else? Okay, all right, so good. So yeah, later we're gonna do another case study, but that's just how things are done. So you're gonna work with someone, and we'll see how people can come up with reports, and then see how we go from there.